are you clicking, Darko? I think they can hear us.
No, they can't.
Are you sure?
Yeah, it's fine.
Okay.
It's fine.
It's okay. You just have to keep quiet for 10 seconds, okay?
Come on.
And there it goes, beepity beep. And we are live. Welcome, everybody, to
Did you
this
hear
week's
us?
episode. Yeah, we were whispering to this week's episode of DevBeardOps, and we're happy to report that everybody on the show has got a beard this week.
Yes.
Thank you for doing the effort, Marcia, to fit in with our, attire. And
exactly, the casual look and the beard. I could not shave my hair, but it was BeardOps, so it was not bald time. So I'm good.
Exactly. we didn't put the bald in the title at all. Yeah.
That would be more challenging.
So for today, as you can see, we have got Marcia on.
I will take my beard off now because I'm used to the mask, but this is very hot.
Yes. We need to make some merch with the beard hats or something like that. we can give out to people.
I shave.
Yeah. There we go. Marcia's back. I actually realized we didn't even set our background. Very bad on us. So, Darko and Marcia, welcome. Today, we are continuing our conversation from last week, which is what is serverless, and basically just having the discussion saying it's not just about using AWS Lambda to run some code in a function. It's slightly more than that. No, we've heard there might be maybe one or two more services that you could use. And last week, Marcia was actually on the stream watching and made some comments, and then we just decided, hey, listen, we actually have a serverless expert in our midst, who even has a whole YouTube channel. So yes, Marcia, you're allowed to talk about your YouTube channel today without paying the promotion jar, which is great. But before we do that, Marcia, since you haven't been on the stream for quite a while, why don't you introduce yourself to our viewers?
Sure. I'm Marcia. I'm also a developer advocate with these two dudes here. And I have a beard temporary for 2 minutes and I was melting. I talk a lot about serverless and managed services. So as lazy as you can go, as I will say, the least amount of code that you can put, the better. And I've been working in the serverless space almost from the beginning of Lambda. So Lambda was launched in 2014, and I started tinkering with Lambda in 2015. And in 2016, I have my first service up on production with a lot of traffic on Lambda. So since then, I have not used any other cloud service for putting my compute. So I've been all Lambda.
Very good, very good. And I'm also a developer advocate. I'm also a developer advocate, and we're all based we're all in similar time zones. Cobus is very far south in South Africa. I'm in Berlin, and Marcia is just a bit to the east in Finland,
and
to
up.
the northeast, and up, northeast.
Very north, yeah,
and up. And hello, everybody who's joining us. So just kind of to reiterate, because I've seen that we have just now started streaming on one of the Twitch platforms. Just to reiterate, this is a weekly show called DevBeardOps, where the beard doesn't matter. It's the beard on the inside. It's the beard on the inside that matter. Yeah, and we like to talk about DevOps, technology, automation, the cloud, AWS, all the fun things out there. And this week we are talking about. Well, actually, we're continuing the chat about what is serverless. Is that a thing you eat? Is that a thing you put on bread? Or actually, how do you migrate to serverless? And Marcia is here to, as an expert, as her long experience with serverless, to kind of chat with us about that thing.
Yeah.
So quickly before we kick off, firstly, the usual audio check. Let us know if you are happy with our audio levels, because we have no way actually of seeing that we have the same levels. And then also, please keep the conversation going in chat. We are looking at it across the different streaming platforms. And Fallen has just pointed out that apparently I made a typo in application. And I apologize for that. I did schedule this stream at, I think, 11. Yeah, I scheduled 11 last night, I think, just before going to bed, which might explain that. So apologies for that. We will try and fix that in the end.
Yeah. Thank you for the audio. Thanks, Lost Audio, for confirming the audio. We just want to make sure that we all are relatively close by when it comes to audio quality and levels.
Yes. Yeah, awesome. Cool. So let us kick off. So basically, last week we had a discussion about what the different serverless technologies are. We touched on a couple of them, but you watched a bit of that show, Marcia. So why don't we put you on the spot and say, listen, you're a serverless expert. Tell us what is serverless.
Well, I think my definition of serverless is I think very close to what AWS definition of serverless is. So I will say that any technology is serverless if it adheres to 4 promises. So that's how you can evaluate if something is serverless or not. And also serverless might be an spectrum. I don't know how you say that in proper English, but it's not binary. So you might have some services that are more serverless than others, and that's okay. It's up to you to pick the one that suits you the best. So when something is serverless, you can think that it scales automatically, meaning that you don't need to worry about if it scales up or down. So you can go to sleep. Your service can go viral, I don't know, in Korea at 3 a.m. when you're asleep, and your website can take everything. You can get all the orders, and then it will scale down as soon as those Koreans go to sleep, and you don't need to have a headache about it.
So isn't serverless something you can buy in a box? I thought the same like DevOps, right? Can you buy 5 units of serverless or?
No. There are many services that are serverless. Oh, okay. So it's not something you can buy in a box, but there's many managed services that are like serverless. So another concept that you need to have in mind is the high availability. So if you're coming from the instance world, you need to put your instances in different availability zones. When you work with serverless services, they're regional. So they will be distributed all around the regions, the availability zones, in one region. Another thing is you don't have to manage infrastructure. So no picking your operating system, not picking your, CPU, storage, or things like that. That everything comes by default. There is some things that you might have the possibility to tweak, but those are more for your configuration than for the infrastructure itself. And then you pay as you go. That's a very cloudy thing, but with serverless, it can get very granular. For example, when you use Lambda, you have to pay for 1 millisecond. It was 100 millisecond before reInvent, and that's something I think it was possible because of how Lambda now is able to really get things in a so granular that you can have a billing of 1 millisecond. So somebody's saying my Lambda takes 0.5 milliseconds to run. Why I have to pay for 1 millisecond? Because that's how it works.
That's actually Goran Opacic. He's our data hero. So I think he's. I don't think he's too serious on this one. So how are you, Goran?
Before, that was exactly the same question when it was 100 milliseconds. My Lambda takes 2 milliseconds to run. Why I need to pay for 100 milliseconds? Because that's how the platform works. I think it's very powerful now that Lambda can really be able to bill you in 1 millisecond. I think that proves the maturity of the service. So I think that was a very interesting move from
AWS. Can you actually run a Lambda function in less than a millisecond? Is there I have not seen it, right? So that's my question.
I don't know for 1 millisecond, but few milliseconds, yes. If you are just doing a hello world or something something very simple, then yes, you can definitely run in a few milliseconds and maybe less than 10 milliseconds. So that was people were complaining. And sometimes you were, one of the things that you can tweak in Lambda is the memory. And when you tweak the memory allocated to your machine, you're also tweaking the CPU. So you can make now, because you are built in 1 millisecond increments, you can also tweak your memory to get faster processing and get your functions to return faster, because now you're built in a smaller increments. Before you were paying, if you make your Lambdas to run faster, you were paying for a lot of idle time. Maybe if it was running, if you give, 2 gigas of memory, so the function run faster, and it was finishing in, 10 milliseconds, you were paying for 90 extra milliseconds. But now, if you really want to make it faster, you will pay exactly for the time that is running. So I think that's really cool.
That's cool. That's cool. I think the way we can, and this also forces people to do more optimization when it comes to Lambda functions.
Oh yeah.
And I initially, and now this has been a debate I've heard with people. You can use something like, now I'm not an expert, but Express.js you can run a full stack application in a single Lambda function,
if you want
right?
to.
If
That's
you want.
what I call a fat Lambda.
Fat Lambda.
has the limitation of the 15 minutes run. So if you can make your function run in less than 50 minutes, and that's one of the migration strategies, is the lift and shift kind of thing. If you have something that is already an express function, maybe you express service, maybe you can add a little bit of tweaking in the API layer and just place it inside a function that you can do. Also, now Lambda support container images, so you can also pack your code inside a container image and then do a little change in the connection between the Lambda platform and your Lambda function, so it works, and then the rest can stay exactly the same. So
yeah, but actually, let's chat about that. I think that's a very good point. How would one go ahead from their own application, let's call it a non-serverless application, make it serverless? How would they migrate to it? What are the things that we should think about when migrating our application? Because that's the question, right? I come and talk to customers saying, hey, you should try to apply serverless practices to your application. They're like, but how? How do I take my big old thing I have here?
My first question to whoever wants to migrate to serverless, because when you migrate to serverless, you might need to re-architect your application to enjoy the benefits of serverless. If not, you might have a very complicated application without any benefits. So my question always, when any customer wants to say, I want to migrate, I will ask you why. Why your application that is working, that is doing what it does, why you want to migrate it to serverless. Some customers might say it doesn't scale, doesn't matter how big my instances are, it doesn't work. I was talking with a bank last week, and they were saying that they migrate to serverless because they were doing batch processing of investment calculations. And then they were using these really big bare metal machines, and they were still not able to scale. But with Lambda functions, it didn't become faster, the compute, but now they were able to put thousands of millions of Lambdas doing all the things at the same time and get the scale that they needed to do these investment calculations that they're super complicated. So that's a really good reason to migrate to serverless and make your architecture serverless. So first, that's my first question.
First question of many. Sorry about that. My camera setup, my cable is a bit tight, it seems. I had to move it now. So I should be back, hopefully, and not just smiling like an idiot for 5 minutes.
It's okay. Smile and wave.
Smile and wave, Cobus. But yeah, I think that's a good point. So, when migrating to a serverless application, or if you're migrating your compute platform to a Lambda function, I think just the fact that you think about, Lambda function only has 128 megabytes of memory or 4 gigabytes or whatnot. That's not enough more.
10 gigabytes now.
10 gigabytes now. Okay. So you don't treat it as that. I mean, you should not treat it as a monolithic place. You do treat it as something, as you said, multiple parallel executions of the same. That gives you the benefit, and you have the ability to scale up. I wrongfully think of it as compute threads. They're not compute threads, but you can kind of think of them as such a way, right? So
Yeah, and I think when you are thinking about migration, you always need to think is that it's something that you want to lift and shift. So for example, if you are not in the cloud yet, maybe your first strategy is to move your application into the cloud and then move to serverless. Because if you're moving from on-premise to serverless, that's like changing everything. Your whole organization is going to be like, what the fuck are you doing? Sorry for my French. But that feeling will be inside everybody's head, because learning serverless is a different way of doing distributed applications, is a new way of doing systems. And then also going to the cloud is a new way of doing things. So don't do everything together.
That's an excellent.
There's that perception where, especially if people just lift the physical they go from physical machine, just put it on EC2. They say, okay, well, now we're cloud native and we're all good. It's like, no. There's still a lot of work to do. That's
the first step.
That's the first step. Yes. But dig into that a little bit. Like one of the couple of ways to go about that. Marcia, what have you seen that people do? Let's say I've taken my physical app that was running in my server room, and I've now put it onto an EC2 instance. It's now running as well, and I want to start moving to serverless. What are the first steps that you would recommend?
I think the best thing you can do after you decided that this is something that you need to migrate is to re-architect your application on paper and think how you would like it to be. What is the parts? Because sometimes from an application, at least this is my experience as a 15-year developer, when you have an application, not 100% of the application is used. Usually it's the 20% that it costs you the pains, the cost, all the problems. Most of the traffic is that 20%. So look at that 20%, identify that 20%, and maybe that's the 20% you want to migrate. And the rest you can leave for when it's put out of production and you build a new service. Because in general, that happens with systems. Nothing is built forever. So start thinking about building microservices and grab that 20% of your application that is very critical and is very painful that you want to solve the problems. So think about that architecture. And then don't lift and shift it into a Lambda function. There is 20 million different services that are out there to help you out to make your application more scalable, more cost efficient, more maintainable. So start getting educated on all the different services. So for example, I think for enterprise, EventBridge is a great service to start looking at. It's an event bus that will help to make your microservices or your functions talk to each other in an event-driven way. You can not only connect it to Lambda functions, but all kind of other managed services within AWS, other accounts, other visions, SaaS providers. So it's a very powerful service that I would encourage everybody to learn.
Yeah, and I'm digging into this comment here from Jabbersoft. Let me quickly pop it on the screen, which is, so iterative change, not a complete rewrite. And the thing here to remember is that when you expose your application, let's say you are hosting it on an EC2 virtual machine, you can put either or both an API gateway or a load balance in front of it. And both of those services actually support you to split traffic based on certain rules, like the path or the host or certain resource headers that come in with a request, which means you can have your main application behind, let's say, one of them, and everything goes there. Then you choose that bit of your app that you want to split out into a serverless function using AWS Lambda. Do that, get that up and running, make sure that it's working, test it to your heart's content, and then you change the input mechanism. Say, listen, for that specific path, so let's say analytics report, if that's / foobar. Let's go with / foobar with a theme for today. Then you can say, everything that goes to / foobar, send that to my Lambda function, and everything else will go to the old one, which means you've now actually...
With the application load balancer, one thing you can do is you can set, I want 20% of my traffic to my new version and 80% to my older version. So you don't even need to pass 100% of the traffic to your new untested in production Lambda function or serverless, whatever architecture. Because when I migrated my first project to serverless, we didn't have that. So one day we were sitting in our chair and we were like, okay, today is the day, let's do it. And we had, in the application I was working, we had around 6 billion views per year. So the traffic was big. So the moment we pressed this button, we were all sweating and it didn't work. So we needed to press it again to revert back. So now you can really pass a little percentage of your traffic to your new thing and try it and test it, make sure that it works, that it can take the scale, and then start pushing traffic. And it has the sticky sessions, so your customers will always be moving into this newer thing if they were pushed in that first time to that place. So that's something.
That's a very interesting point, because as you say, serverless is on a spectrum, but also migration to a serverless application is on a very big spectrum. It's not all or nothing. You can have portions of your application still be very much non-serverless, and
that's totally fine. You should not aim for 100% serverless application, because that's, I think, maybe in a greenfield environment you can achieve it, or maybe you cannot even achieve it, because there is a place and like use cases for instances and
correct, absolutely. I mean, serverless and Lambdas are not an end-all solution to all the things. They are, maybe, but sometimes things you need to work with potentially a lot of data, fast disk access, and a whole lot of things, and legacy software as well. So it's fine to have a mix and match of your architecture as well, and especially when you're migrating.
So would you say that It depends. Okay.
Wait.
Oh, he's got his little thing. Wait, he's got
It
his prop. There we
depends.
go.
Oh, you
And it's still not on.
printed.
Yes.
No, but he still needs to put it on cardboard and still needs to laminate it.
I know. But actually, somebody told me that this is bad. You should not say it depends. The proper answer is, let's have a look at your architecture and discuss it, what the right way is to do it.
We are developer advocates. We don't look
No. Darko. Just quickly, you've now gone from giving advice to someone to going into consulting.
Exactly.
Oh, okay. Well,
Let's talk about your architect and how we can help you, especially if we can give you 5 DevOps units. You can get discount if you take 10.
And free serverless.
yes,
Of course,
yes. A DevOps unit comes with serverless as an addition. But Cobus, you last time spoke about, especially when we talk about not having your entire thing as serverless, you called it strangulation or suffocation. What was it called?
The strangler pattern.
Strangler pattern. Tell us about that.
Yes, the strangler pattern. Yeah. So it's often you would hear that come up in talks where they say, how do you go from a monolith into a microservice architecture? Because like we've just discussed, going and doing one massive rebuild of the system and then releasing it as a big bang, like, hey, it's release day, let's go. You will have a bad day. I mean, that's guaranteed. I've never heard of somebody who did that who actually had it go smoothly, especially from monolith to microservices in one go. So what you do is you take your monolith, your app that you just moved into a VM, and now you want to start moving to serverless. And then you decide, what is the first bit that I'm going to do? So you define that, rebuild that one part, make sure that it's working, and then you start sending traffic to it and make sure that it's working. And then you take the next part and the next part. So the concept here is like it comes not from strangling people, it comes from a vine on a wall, where if there are a couple of cracks, the vine will slowly start breaking down the entire wall after time because it gets the root in there and then starts going and pushing it open and then breaking it in the end. So that's where the idea of strangler comes out. And that's how you do. You start chipping away at your monolith or at your old app that you want to change the architecture to instead of trying to do everything in one go.
Yeah.
And how do you pick what to choose? That's a question I get. Like, I tell them, hey, you should just slowly pull out things from your monolith.
That's a great question. And there was one example from a serverless migration from the comic relief that they did a serverless migration. And they have, this is one of the reInvent talk a couple of years ago, and they started presenting like, well, we will start the migration with a service that nobody cares, something that is very not used, so we are in a safe place to learn. So they started with some image gallery or something like that, but it was not relevant. If you don't know what Comic Relief is, it's an organization that takes donations for, they take the TV over one day. So basically it's one day of a lot of traffic, a lot of donations, and donations are very precious because if you fuck one, then people will lose the trust in the system, and you don't want people to get billed twice. You don't want people not to get billed if they make a donation. So they are very, very important type of transaction. So they wanted to migrate that to serverless because having that infrastructure set for one day a year was extremely expensive, and they needed the sponsors basically to pay for that in order to get donations, and it was pointless because they were wasting so much money. So they wanted to migrate to serverless, but instead of starting from the donation service, because that was a very delicate one and the team didn't have the expertise, they started for something that nobody cared, that it was an image gallery. So then the team started becoming more empowered. They were very free to pick the technology and to decide what to do, and I don't know, play with newer things and shiny things because the business stakeholders were not over them. This was an image gallery, just like, who cares? But if they were saying, hey, I'm going to migrate our main kind of thing into serverless, this has been working always, but I can make it better. The stakeholder was like, hey, wait. How you're going to deploy something that you never tested. So then they started by doing this, and then they start taking over a little bit of the big monolith that they have and start taking services that were not that big. But then in some point, they decided to go to the donate service. So instead of starting and take everything that was useless and do everything until they get to the bigger thing, they tried one or two services to get expertise, to get empowered, to understand how this works, and then they went to the big 20% that I was meaning that painful part, that it was expensive, that it could not handle the load, that was giving them a lot of headaches. So I think that's the right way to go in a team without experience.
That's an excellent point. So I think just choosing things that are not, I wouldn't call them too important because that's bad, but I would say also.
But there's services. They're part of your applications that are less used and they're less critical. Right. Let's call it less critical than less important. That critical can mean no other system depends. Nobody's business depends on it. So, for example, in the case of Comic Relief, if the image gallery was down, well,
exactly. It wouldn't hurt the output. So we talk about business outcomes of your application.
Exactly.
Does a specific part of your application push towards the business outcome? Maybe yes, maybe no. So this is a prime example of a thing you can try to convert to serverless. And I love that fact. As Kobe says, you would never go ahead and just convert everything to microservices on a single Friday afternoon. You would take little bits, push, and that gives you the ability to just remove a code base from your monolith, right? Take something out and build it differently. And the most amazing thing I found is that you can replace a lot of that by services, right? So if you have a part of your code base that's authentication, why not use something else? Cognito, right? Or you have something else that does some processing, ship it out to a different service. If you do video, what is called video encoding, Elemental,
transcoder,
right?
Elastic transcoder,
exactly, or that. So all of those things are can help you also hey, I don't have to even worry about this code anymore. There's a thing, let me plug it in as a serverless service and it will do my job. So
and that's why it's important that time for the team to get educated, because it's very hard to learn the different services that are available just by reading AWS documentation. You will spend a whole lifetime. So if you start getting your hands on something, then you start realizing, this is how Dynamo works, and this is how Aurora works. This is how queues work. This is how step functions work. This is how this works. So I will definitely encourage hands-on.
I actually want to share something that I found very recently, because I'm digging into some of our documentation and things, is we have a very nice hands-on workshop type thing to go through all the different databases, and covers DynamoDB, Elasticache, Neptune, and DocumentDB. So I'm going to drop that in the comments quickly. And apologies if I sound like a robot at the moment. I had to get up quickly because my daughter is back from her third day of school. Ooh. And it's going a little bit wild outside. So if I do start sounding like that, it's because someone is screaming in the corridor. Apologies. Yeah. But okay. The interesting thing that you touched on there is that whole point of picking somewhere where it's safe to make the change. Because that's often, before I joined AWS, I did a lot of consulting. And often the consulting involved, how do we automate our systems? How do we move it to the cloud? How do we do that? And the answer is always, first, if you don't have the skills, take something that nobody cares too much if it breaks. Exactly. Because the fastest way to lose trust from, especially management, because remember, management is always scared of change because that might impact the actual bottom line or what the app is supposed to do in your customers. So if you say, listen, we're going to move to the cloud, they're already like, we've heard it's good, but we're worried why our servers that we hug, I love the term box huggers, by the way, why do we need to change? It's going to cost us money. Why do we want to change? We don't need to. Yeah, Darko and his little server as well. And so exact same advice, do small things, small changes, and also have a backup plan. Like, what happens if something goes wrong? How do I go back? Now, in the case of the strangler pattern that we discussed with a load balancer, if that Lambda function that you just did stops working, guess what you do? Application load balancer, 0% traffic. Then it's fine.
Exactly.
Yep. Yeah. I have a little piece of advice here. As Kobe said here, you may make a mistake while you do something, so you need to pick something that is not too important. Let me tell you a secret. You will make a mistake, no doubt it. You will for sure make a mistake. Be ready for that. It will not be smooth. So if you practice something, it sounds weird, but if you try your migrations on things that are not critical, that's fine. Don't go ahead and migrate your main customer user base or something that is very important.
And one cool thing of serverless is that you can build your whole production infrastructure as testing and or dev, and you can load test it, and you can sometimes with on-premise that you cannot do, and even with instances might be very expensive to do. But with serverless, you should be using infrastructure as code, and then you can get your testing environment up and then go and fire the traffic. You can even capture the traffic from a real production day and then replay it in your new serverless thing and see how it reacts. And you can do this test with not much work involved, because capturing traffic, you have the API, so you might need to just add a couple of recorders of the traffic. So you can really play back and see what happens. And with serverless architectures, that's pretty straightforward to just deploy a new environment and then tear it down when you don't need it anymore. And I think load testing for serverless, sometimes people think, but it scales automatically. Yes, but there is Darko? But, yeah, there is soft limits. So if you're starting new AWS account, you will start finding the soft limits of managed services. They all do have them. They're there for protecting your wallet, so nobody can, hack your Lambda functions and to do million invocations at the same time. They have limits, so you need to know. Yes, you need to know what are your limits, and if you can increase them, yes, it's one ticket to support. It's very easy, but you need to know your limits. And then also know how your services connect to each other, because one service might be totally cool, another service might be hitting the soft limit, and sometimes this is an asynchronous communication, so you might have not idempotent functions. You know what are idempotent functions?
Idempotent.
Yeah.
I don't know how to pronounce my English, but that's a very important concept when you're building serverless applications. What the documentation of Lambda says, that functions will, and this applies for all the event services. So for queues and for Event Bridge and for other services, events will be sent, or functions will be executed at least once. So that means that you can receive events twice, the same event, because the platform thinks that it might not arrive, so it might send it again. The function might get invoked again. So your functions always need to produce the same output, if they have an input. So for example, if you're creating an account, every time you receive a message and you're creating a new account, you need to have mechanisms in place that to know that this account was created already and don't recreate it, and things like that. So you can make your architecture safer.
Idempotence is very important, and especially on a very distributed systems like a serverless application where you have a lot of different things working at the same time. It is very important that if you do a thing twice, you do not repeat that unless you really want to do that. Exactly. So that's a very good point. We have a question here from first of all, comment from Dan. No matter how much testing you do, your customers will always find an edge case. That is absolutely true.
They're like toddlers.
Yeah,
you
exactly.
Prove safe your cows, and then they learn how to use the stairs, and they reach farther.
Correct. So that is a very good point. Try to learn from that. Learn how your customers break your application and use those tests in the future, even though they're edge cases. Makes you more confident on things.
Sorry, just quickly on the previous one, there's that famous statement that says everybody has a testing environment. Some people are just lucky enough that it isn't their customers.
Exactly. Very good point.
Yeah.
There's a question here from JavaSoft. Any suggestions for test frameworks, runner/orchestration, AWS services, just customer Jenkins pipelines, and Selenium, other popular frameworks?
I think there is a lot of tools, and you should use tools. You should not do it manually. That's my first recommendation. And whenever you're doing anything, I would encourage you to pick one tool and try to stay with that tool, so everybody learns that tool. And if you are inside AWS and you don't have any other tool, go to the AWS tools. They come with all the permissions and the security that for accessing, for example, code pipeline is so simple to use. You can use Lambda as integration tests. You can do really easy use code builds. So all the permissions are already there, and it's very easy to integrate. If you use Jenkins, then you need to manage the access to all your services. So if you don't have anything and you don't have experience in the team, I will always recommend learn AWS tools. It will make your life so much easiar.
But I love the fact that you can just use Lambdas for a lot of things, right? Sorry, Lambda functions for a lot of things. I use Lambda functions as part of my testing. Just they would do things.
It's so easy.
So just quick follow-up on that is like for the people who do use Jenkins, I'm a long-time user of it and I still love Jenkins. If you use EC2 worker nodes, you can actually use the IAM policy attached to that instance for your permissions to integrate with other services as well. So then you don't have to go and enter manual API keys into the configuration. So just keep that in mind if you do want to go that route.
That's a good point. There's a comment here from, where did I meet it? Somebody was somebody mentioned SAM. Yes, Krishi.
Oh yeah.
Any love for SAM? I love using SAM and Amplify CLI to quickly prototype things. Serverless application model. Yeah. So it's wonderful.
I love SAM. I use it. I think I use it now evenly with CDK. And when I choose CDK, when I have things that are more non-functions or API gateway. So if I need to build a microservice that might have an Aurora or might have, I don't know, something that is EFS or might have a VPC or things like that, then CDK is great. But if you're just doing API gateways, dynamos, and functions, SAM is really simple to get started.
I love SAM because I can set up a co-deploy canary deployment in a single line.
Yes.
Like if I want to show off canaries, I find it easier to do it in SAM than to do it in CDK. Although I have not dug into like SAM and CDK integration, which apparently there is a lot of now. So, but I have a question for the audience. Tell us how you deploy your serverless applications. Are you using CDK, Terraform, SAM, serverless framework? Tell us what you're using. We want to know.
The console.
The console. Ooh,
no. Humans.
Humans, yes, we have labor to deploy our Lambda functions. But yeah, tell us how you do it. Yeah, it'd be great to know. We have Terraform users as well.
I'm Team Terraform in case you're wondering.
That guy. A question from Ezea Diugu. If I deploy an application on Fargate containers, will I have to provision storage, EBS, EFS in addition to Fargate containers? No. Simple as that. What? Okay.
It depends.
Maybe, if you want. You don't have to if you're using Fargate. You can attach EFS to Fargate, right? I think you can.
So I imagine you can attach it to Fargate.
So let me quickly segue into this. Darko, that meeting that we are having tomorrow night to set up the guest for our next stream next week, I believe, on the 14th.
Ooh,
yes.
What a segue.
We will have someone come talk to us about EFS, which is the Elastic File System that you can attach to, drum roll please, Fargate, and Lambda functions, as well as a whole host of other things. So we will be addressing that next week in a lot of detail. Yeah,
next week, make sure to join us as well on the stream. We're going to have a guest from the AWS, one of the AWS service teams covering EFS, and we're going to talk about how can you actually elastically expand the storage on your file system, on your functions and Fargate systems. So should be pretty fun. But yes, you can, but you don't have to. That's the thing. I see a lot of comments here. People see Javasoft is using Terraform. iCodeCraft uses serverless framework. Dymo, CDK, Krishi, SAM, Alexander Gamerman, CDK pipelines. All right, we there's a lot of folks here using a combination of things. I like that.
Well, that's the world out there.
Yeah, exactly.
Imagine people use different software.
Wow. It's not a single mindset. Wow. I've never used a serverless framework before. I know
it's
that
very similar than SAM, but it has. I like the plugin system.
Okay,
so
that's very cool.
People can extend the framework from the community with plugins. So I think that's a really nice thing from serverless framework.
So let me take a step back now. Let's say I'm owner of a news company and I have a software that. A CMS, right? Whatever. We built it. And I want to take a specific piece of that software, let's say a tagging utility. It's a module in my application, and I want to create that as a serverless platform, or I want to start migrating that little thing. Where do I start? What is the thing I need to do? What is the thing that you, the engineer, the developer, needs to do there right now?
Yeah, I think in serverless applications, the complexity is in the architecture and not in the code itself.
Yes.
You might end up with, we said that Lambda functions should be simple and do one thing and one thing only. So you might end with a lot of functions and other services. So I think the first step for anybody when they decide what they want to migrate is to sit down and understand what are the components, how the messages flow from one component to another, what is the need of synchronicity versus asynchronicity. My English is great for these complicated words, but that really changed. So for example, in my previous life, we had to migrate a component, and that because we were doing a video platform and we wanted videos around the world. They have different copyrights in different parts of the world. So people in China cannot see the same content that people in Finland or in South America, copyrights. So we needed to, when we were doing this video platform, we needed to have different metadata for different users. So how we did it in the past? Well, every time a user made a request, we calculated that on this is previous serverless. We calculated that on the server side and we returned the right metadata. Then we realized that that's pointless, that we can do this every time we update a new video, that we updated a couple of times a day. There was not that many videos. We were a small platform for video distribution. Every time we put a new video, it was easier to run an asynchronous job that calculated all this metadata and distributed in the right countries when it finished. So basically now the customer will come and it will go to the edge, get the right file, and it was way faster for them. So that's a re-architecture rethink, like thinking from a very simple thing, I go and fetch a piece of data, to I can do this beforehand, I can prepare it, and I can serve it to the customer right away. So we reduce the amount of compute like incredibly, even though we were processing a lot of files at the same time. But Lambda gave us the capability to do that processing because it scaled. So we were processing, I don't know how many countries are in the world every time we uploaded a new video. But that was it. We did it once for every video. And so that kind of rethinking is very important to take advantage of the serverless architecture. So you need to understand what is the problem that piece of code is trying to solve, how your customers are getting served, and your customers can be your end customers, other microservices, internal service, whatever. So think about that and think how you can solve the problem in the most asynchronous way possible. That will be the easiest path. The more synchronous you need to go, the more complexity you will need to add in your system. So that's why it's super important to try to think in the most asynchronous way. Think about item potency, think about how things can be done in in a different time frame than when they are requested.
No, definitely. This is also a good time then to chat a little bit about step functions, because they often help with this, because step functions is a way to build a state machine where you say invoke something, and then if it succeeds, do the following thing. If it fails, do the following thing. You can build this whole state machine in JSON, and I believe we just released the YAML version of it as well in terms of defining it. And what makes it so awesome is that that's something that you invoke. Initially, it was just a Lambda function. So you could have Lambda function 1, 2, 3, and 4 that you would invoke. But now it's actually expanded to include a whole host of AWS services. Even, for example, spinning up a Fargate container. So let's say we get to this.
Or SageMaker or other step functions.
And what makes it so cool is that some people might go, well, I don't need a state machine, or why would I need this? And the example we have on the site, which actually makes a lot of sense because it's easy to visualize, is I want to book a holiday. So first function is book a flight. If it succeeds, book a hotel. If it succeeds, book a car. That's the happy path. Now let's say something went wrong. Book a flight, done. Book a hotel, done. Book a car, fail. Now I need to roll back. Now I need to unbook the hotel, unbook the flight. And what you do is you can actually visualize all of this, the whole flow of it inside that state machine, which makes it super, super useful.
And also now these state machines, you can hook them directly to API Gateway. So basically you can build the state machine right away. It's so simple. And now, since Reinvent, you can do it in a synchronous manner. So before, basically, API gateway was sending an HTTP request, and the state machine started executing. And then you needed to have some system in the backend to manage the callback to return the result. Now, if your step function lasts less than 29 seconds to invoke, that's the timeout from API gateway, you can basically return the result right away in your response, in your HTTP response. So that empowers people with the 1 millisecond billing to do functions that do one thing and one thing only. And those functions are easy to test. They're more secure because when you are creating functions, you need to give permissions, and you need to give functions are born without any AWS permissions. So you need to give permissions to the resources that they are going to touch. So if you have a very fat function, you might need to give permissions to a million things. But when you have a very specific function, maybe sometimes they don't even need permissions because they are doing calculations or computations. Sometimes they are just storing something in Dynamo, so you just give the storage permission. Sometimes they are reading, so you just give the reading permission. So that's why I really, really like step functions, because they really enable you to build good services that are easy to test, and they also externalize a lot of the logic. So all those paths, they're handled by the step function. So you don't need to add the logic of what happens if this fails in the function itself. That's externalized in the state machine. So
yeah, those nested if else, because I still remember, like, I had a job at one point where, if you've ever dealt with an ORM, you may know about managing the transaction of your database, because how it works is you initiate the transaction, then you do multiple changes, and then you either close the transaction or you do a rollback on the transaction, so it changes everything or saves everything or reverts everything that you did to the database in that transaction. And that specific piece of code, the happy path was easy to follow, but there was a certain thing where if there was a rollback, you actually went through 4 different classes, and that class, the last method, and then get this, was a transaction rollback. And the first time I saw with this, like, but there's no transaction here. Why do we have a rollback? And then you're like, oh, wait, hold on. Up here somewhere we created the transaction, so you don't have to deal with that kind of like crazy logic inside your system.
Yeah, especially Marcia mentioned that how complicated architectures and systems can be in serverless environments. So I think orchestration with step functions, is orchestration the right word? I guess it is. The workflows with step functions.
Orchestration.
I will call it orchestration, because this is like you're orchestrating the business logic, how it happens.
So doing that helps a lot. You don't want to get stuck in the middle of something breaking, and like, how can you roll back and do those things? Especially, I like the analogy of a monolithic application uses rigid connection. It uses like your like rigid I don't know how they call it, axle bars on vehicles, right? You have to rigidly move those things. You rigidly move things, and you move other things, and they have to move together. On a proper serverless architecture, things are much more decoupled. There's a string or there's a message, a light, or something that kind of is much more. It's asynchronous. You don't have to wait for other things to happen necessarily for this thing to. And then hence rollbacks and walkbacks are kind of complicated. So you should have something like that.
And also, for example, if you're calling an external HTTP, you might need to have some kind of circuit breaker pattern in the way, and that's kind of quite easy with step functions to do. So if you want to do that inside your Lambda function, you might be blocking the Lambda function, you might be having it stuck, but if you have that built in the state machine, is way easier to handle. So I totally encourage people for within a microservice to use the step functions. Don't use step functions outside of the microservice, because then you're coupling quite high those microservices together. So for communications between microservices, I will encourage people to use something like event bridge, like an event bus thing. So then the messages are flowing and things are more decoupled, because when you're creating the state machines, it's not that you're coupling the functions together, but this state machine has a lot of coupling, in the sense that we have this state, we have this state, we have this machine, we have this thing. So if things change, then everything can break if you don't have the control. So
I mean, it's exactly the same as coupling your databases, where if you've got a database with multiple services touching it, if I change a service over here, or this service needs a database change, this service is changed. Now all of a sudden you've got your functions. If this one changes, this one needs to change because guess what? They are in the same state machine.
No, if they're inside the state machine, in general, the functions don't need to change, but the state machine might need to change because the state machine has the link to all these functions that are inside the state machine. So they have the Amazon resource name, they need to point to something. So if you have a change in there, then you need to go and update that. So there is some coupling there. I would say that if for inside your microservices, that's totally cool. For outside your microservices, when you don't have more control on what is going on, use something more asynchronous like Event Bridge.
Sorry, just to clarify what I meant. What I meant is if you have two separate microservices in Lambda functions, one state machine spanning both of them, that might get a little bit messy at some point. Yeah, sorry. I think neither applies to three people as well, has English as a first language. We are all second-rate English speakers.
So there's a question here.
A couple of questions
there.
Hugo, Garako.
Okay, so first question from Anshul. Let me pop it up on screen. Will it be possible to discuss about callback waits for empty event loop and when it should be used in a Lambda and how it is different from a synchronous version of a Lambda function?
I'm searching for that because I don't know my names of things right away off my hat,
Okay. We can come back to that one. So, and the other question coming in,
and he's coming from my channel, so just hope it doesn't comment in this video, and I come back later asynchronously to you.
Yeah. So just leave a comment on Marcia's video as well, and
asynchronously.
And Cause, hello, Mr. Cause. Let's call you Cause. Hi, a total beginner here. I understand the hype around serverless, but in which scenarios should we not opt for serverless? So
that's a hard question.
What do you think? When not serverless? Tell us.
So the first very, I would say, easy answer is if you have a process that needs to run longer than 15 minutes. So think data transformation, ETL type operations, some kind of heavy processing that takes more than 30 minutes because a Lambda function is 15 minutes because a Lambda function's maximum execution time is 15 minutes, which means if you want to go longer, you need to figure out a mechanism that can store the data. So firstly, figure out how much before the 15 minutes do I need to start storing the data to not be cut off while I'm storing the data and then load the data again and restart. So that's the first obvious example.
And then also my next question for you is, can you re-architect that in a way that Lambda functions, state machines, and services that ingest streams our data can do it? But that's a totally different question.
That's actually a very, very fun question because the easier answer to that at the moment is yes, especially since let's think you want to run that in a container because that that's going to run long. So you might want to use, let's say, Fargate to run that for you. Because you can now use containers with Lambda functions. If you build your app in a way that the functions are all available in a single container and then they get invoked as different Lambda functions, you can have that same container be spun up in Fargate and actually then handle that processing for you. And you can string all of this together nicely with a step function.
Yeah, so and let's say that serverless, Fargate is a serverless service. Even so,
there's a server underneath, don't worry.
Yeah, well, there is servers underneath Lambda as well, and there is servers underneath S3. But I'm saying that Fargate is a serverless service. It applies to these four promises. You don't have to manage infrastructure. They don't even appear in your EC2 console, like those instances. They're from AWS pool. So enjoy.
No, definitely. The other time where it starts making sense, we get that balance is that there's this interesting curve in terms of cost, where if your API is not very busy up until a point, and very busy is actually a very large number in this case, serverless makes perfect sense from a purely billing perspective. Then there's this gap in the middle where if you get above a certain range but below another very larger number, that it makes sense to rather go the route where you've got an application load balancer as well as virtual machines running it. Because you can apply things like, if you've got a base load, like savings plans to get high savings, which you can also apply to Lambda. That's a whole longer discussion in terms of how to balance that costing out. But it just works out with the way the service costing is structured to actually use an application load balancer backed by an EC2 instance. And then at the top end again, it becomes it depends type scenario where there are ways you can be a lot cheaper with serverless or a lot cheaper with actual virtual machines or containers. So it gets a little complex.
I had a discussion with a customer a long time ago. They actually use Lambda functions in a wrong way. So they've basically used Lambda functions for a lot of data transformation, and the Lambdas would run longer than 15 minutes. They would have a piece of their code was to re-invoke the Lambda functions once it reached the 14 minute mark.
Ow.
And it was like, oh, this is very expensive. Yeah, maybe batch processing is better or something, or just containers. Yeah. So that's a bad way to do it.
Yeah, I think the question that it should be asked here, when Lambda function is not a good case, because I think serverless is such a broad term nowadays. As I was saying, Fargate is a serverless component, and there's many other things that are still serverless that might run for more than 50 minutes and allow you to do all kind of things. So I think where Lambda cannot be used is a better question. And I think there, yes, you can start applying those 50-minute rules. And like sometimes you have a lot of data and you still don't want to, put it in a Lambda function. You can. Now I think that's something quite interesting. When I started speaking about serverless in 2016, I started giving my first talks about serverless. I always have a slide of what Lambda cannot do. And I think nowadays my slide doesn't exist because it can do so many things. And I have seen customers do all kind of weird things, really, that I cannot tell you what Lambda cannot do. Well, they cannot run more than 15 minutes, that's for sure. But the rest...
long time ago, Lambdas were 5 minutes limited to 5 minutes. That was the initial one. So, and I recall people use Lambda functions then. I mean, serverless applications were starting out then, but people used mostly Lambda for like some glue logic, just basically a thing that will do a thing if you do that. So
orchestration inside your AWS account and things like that. So I think and also it's about how you orchestrate your application. It depends the knowledge you have inside your organization. If you are very good at doing things inside one machine, like maybe rethinking the whole pipeline to have a super serverless lean processing is a pointless exercise because you are not saving anything. But maybe if you're starting from scratch with a very serverless team, they will not build a process that is batch inside an instance. They will think on how they can split it into parts, use managed services, and put it in a serverless pipeline. So that's everything can be done in multiple ways. So it's
So there's another fun question here, which is what sort of automated testing can you build around Lambdas and step functions? Marcia first.
You can use Lambda functions to test Lambda functions.
But what tests to test though?
What tests to test?
I think there is when you're building Lambda functions, everybody's like, oh, you cannot test it locally. Well, you can. I will not recommend it. But what I will encourage everybody is to have Lambda functions that do one thing and one thing only. And then inside your Lambda function, you can always test your business logic. Like, what is the business logic? And you unit test that. If that's called external service, you mock it, and it's a unit test. It doesn't communicate with the exterior. Basically, you should not need the internet to run that. And then you deploy to the cloud, and then there you will have your integration test. And your integration test you can build in all types of formats. You can use a traditional way of doing integration tests, or you can use Lambda functions to test your deployed Lambda functions, because you can, for example, if you're building a code pipeline, you can pass the parameters, what is the URL of the API gateway, for example, or the ARN of the Lambda function, and you can invoke it. And there you can test that the Lambda function is connecting to the services that it should be connecting, and it's returning what it should be returning. One thing here is always the challenge. Should we do this in a staging environment? We don't have the data, how to manage that. And I think that's very depending on what you're testing and what kind of critical data you have. The harder it becomes when you are doing transactions, and there you might need to have a sandbox environment or things like that, so you're not spending random money or calling third-party services. So it's always good to have some sandbox account. Usually third-party services always allow you to have a sandbox account that you can run your test against.
Yeah, Kubis and I actually discussed this last time, and we talked about like how to do proper testing and how to do all of those things. So there's a whole discussion about how and where you should test. So go to our YouTube channel. I think it should be somewhere around here. Not Kubis, not Darko. You cannot see it from our names, but it's not Kubis, not Darko. That's the name of the YouTube channel.
We can do this quickly.
That's one there. So see,
this is I didn't make a banner for this one. Apologies.
Yeah,
but you can see it over there.
not Cobus, not Darko. Check it out there. There's recordings of previous streams there as well. So, and I think we need to slowly wrap up here. And yeah,
but there is one question I want to take and point this person to, because I think we should. There is this Pepe, front-end developer, and I would really recommend you Amplify. Just go to my YouTube channel. I hope like 20 videos on Amplify, on how to get started from nothing to building something with Amplify, or then just go to the Amplify documentation. They have really good tutorials there if you're using something else than React. But they have iOS, they have Android, Flutter, Vue, Angular, whatever you're building, there's sure an integration with Amplify. So, and
sorry, I now have to be the stern dad and say today we have a very hard stop at 1. So thank you everybody for joining us today. Marcia, thank you. We hope to have you on this stream again soon. And thanks for joining us this week. And apologies for the very abrupt ending, which is going to be in 3, 2, 1.
Bye.